So students, now let us see the few more properties of the square numbers. Now here one of the class activities there to observe the pattern of a triangular and square numbers. Now how much for the 1 we can prepare the triangle like this way. For the number 3, the triangle with the 3 dots. Number with the 6, again a triangle has been prepared, and number with the 10, again a triangle has been prepared. Now, what we can see here, the number 1, 3, 6 and 10 are the first 4 triangular numbers. Now, they are saying to find out the next 5 triangular numbers. If you try it, definitely you will be getting. Now, add any 2 consecutive triangular number. Consecutive word, they have used it. That means if you are taking 1, then it should be added with the number 3. If you are taking the number 3, then it should be added with the number 6. And if you are taking 6, it should be always added with the number 10. So, on adding, you can find that these numbers will become a perfect squares, because we know that 1 plus 3 which comes out to be 4, 3 plus 6 which comes out to be equals to 9, 6 plus 10 comes out to be equals to 16, 10 plus 15 comes out to be equals to 25, like so on. So we can say that adding any 2 consecutive triangular number gives us the square numbers. Now we can also see this by changing the type of this triangular. The number 1 will be written as it is. Number 3, I can prepare a right triangle like this way. Number 6, you can see here, again I prepared a right triangle. And number 10, again I prepared a right triangle. Now, if I start adding them, that means this black dot, if I replace it here, it comes out to be equals to a square. So, therefore, it's concluding that the 2 triangles, if consecutive triangles, if you add it, the result will become a square. Now, similarly, 3 and 6, they have added here, and it becomes a square of 9. Similarly, 6 and 9, you can place it here above, just above this one, and definitely will get equals to 4 square. So, we can conclude that when we add together the square numbers as a sum of the 2 squares. Now, here there's another type. 3 square plus 4 square equals to 5 square, which comes out to be equals to 9 plus 16, which is equals to how much? 25. Such numbers like 3, 4 and 5, they are said to be called the Pythagorean triplets. Pythagorean triplets, a very important concept here. The number 3, 4, 5 are said to be the Pythagorean triplet, named after the famous Greek mathematician. Now, we have generalized this formula where a square plus b square equals to c square, where a, b, c must be the what? They should be a positive integers to form a Pythagorean triplet. That's very important condition here, that a, b, c must be the positive integers. That means these are the sides of a triangle, the sides of a right triangle we can say. So definitely the side has to be positive. So therefore the value of a, b, c are positive here. So it's a very important concept here, that is a square plus b square equals to c square. One of the example they had given here, and this example is also said to be the consecutive numbers also 3, 4, 5. As you know that these are the consecutive number. This is the only consecutive number which are Pythagorean triplet. The other Pythagorean triplet, whatever you will be getting, they will not be consecutive numbers. That means they are not regular numbers. They are apart from that any other numbers they are coming up if we are taking a jump of 5, 10, 20, whatever, so on. Now, here they have seen another type of property they want to explain. They have taken the 2 consecutive odd or even numbers. In these odd or even numbers, what they have done it, they have multiplied. The result is coming out to be 35. If you multiply this thing, 4 into 6, which comes out to be 24. 10 into 12, which comes out to be equals to 120. 19 into 21, which comes out to be 399. Now you can see that here the number 35. As you can see here, the number 35, this can be written as 35 can be written as 6 square minus 1. Square of any number minus 1. Similarly, the number 24 can be written as 5 square minus 1. So it's another property which is stating that if you multiply the 2 odd numbers or 2 even numbers, they always come in this particular relation of the square numbers. So this is another pattern where you can find that these numbers do exist. Now what they have done it, they have tried to explain why this is happening. This is happening because of the one of the concept of you have studied in the 7th standard. The formula is a minus 1 into a plus 1 equals to a square minus 1. A plus b into a minus b equals to a square minus b square. In the 7th standard, this was the 3rd formula. Okay, so using this formula, they have derived it. It's actually coming from this formula. Now, the 6 square minus 1 was written here. The 6 square minus 1 can be written as 6 plus 1 into 6 minus 1. And 6 minus 1 comes out to be 5, and 6 plus 1 comes out to be equals to 7.